Hello everyone, this is Tiger. Today we will talk about the second half of the paper 2018. So let's take a look at what interesting questions we have this time, alright? So the first question is a number theory question on divisibility. Okay. Sorry for my poor writing there. So, alright, first of all, this question is asking you that a 5-digit number with 2 of the digits unknown is a multiple of 15. Well, first of all, we need to know if a number has to be a multiple of 15, it is a multiple of 3 and a multiple of 5 at the same time. So now for multiples of 5, we know that it's going to end with 0 or 5, right? Which means that Q is going to be equal to 0 or 5. And as for the multiples of 3, we know that we need to add all the digits up to see whether it is divisible by 3. So when Q is 0, 8 adding 6 adding 9 adding 0 is 23, is it? Yeah, it's 23. So now we know that P adding all of these is going to be a multiple of 3. Which means that it can be 24, 27, or 30. Can it be 33? No, because P can't be 10 since it is just one digit, right? So it means that P is going to be 1, or P can be 4, or P can be 7. There are 3 different cases for P, right? So when Q is 0, there are 3 possible P's. And when Q is 5, we know that 8 adding 6 adding 9 adding 5 is 28. We also know that P adding 28 has to be a multiple of 3. So it can be 30, it can be 33, it can be 36, but it can't be 39. Which means that P is 2, or P is 5, or P is 8. Those are the 3 other possibilities. So altogether, we can see that there will be 6 possibilities. 3 of them when Q is 0, and 3 of them when Q is 5. Okay, so that's how we can solve this problem. And for question 17, so this one is pretty clever. I would say is a very clever question. It's about areas in geometry. So, well, it is asking you what is the value of x there. Alright, so, well, of course, we can just try to find the height for this small rectangle, add it on top of 3, and then divide it by the area of 25 to find x. Of course, that is one way we can do it. The other way we can do it is that we can try to complete this rectangle there. And this part we complete is going to have an area of 3 times 4, that is 12 centimeters squared. Because the length is 4 and the width is 3, right? So now you can see that on the right hand side, 13 and 12 is making a total of 25 centimeters squared. And both rectangles, they have the same height. Which means that 4 times height is equal to x times height. Which means x is 4, or 4 is x. So that's how we can find the area. That's how we can find the value of x. The length of that rectangle there. Okay? So that's for question 17. And as for question 18, it is a miscellany question. And it will be on optimization. So, it says that between them, the 2 5-digit integers m and n contains all 10 digits from 0 to 9. which means that I'm using 5 of the digits in M and the 5 other digits in N. So what is the least possible difference between M and N? Basically, I want the least distance between them, or like the smallest gap between them, right? Which means that I want the larger number to be as small as possible and the smaller number to be as large as possible, such that it gets closer to each other, right? So ideally, the 10,000s place are just going to be 1 away from each other, right? And then for the remaining places, so first of all, I'm just writing down the 2 numbers with nothing filled in, but I'm putting the digits there. So these 2 digits should be 1 away from each other, right? And for the others, say the first one is the larger one and the second one is the smaller one. The larger one would like to choose all the smallest digits and in the smallest order, right? Where the smaller one is going to choose all the largest digit and put them in the largest order for the remaining 4 digits. Which means that I will have the larger one going like 0, 1, 2, 3. And the smaller one goes like 9, 7, 8, 6. That's how the smaller number can get as large as possible and the larger number can get as small as possible. And then we can realize that there are only 4 and 5 remaining, which means this is 5 and this is 4. Now you just need to do a subtraction to find that it's going to be 247. All right, so that's how we can find the answer for this question. Okay, so that's it for this one. And the next one, I would say that this one is kind of hard. So if you haven't learnt about how to manipulate the nets before, maybe you don't know how to do this question apart from imagining. So it belongs to spatial recognition, of course, and it belongs to nets. Basically, what I want to let you know is that if you have a row of 4 squares, and whatever is on the side of it, that is, you know, like trying to complete the cube, you can always rotate it for 90 degrees and it will get to the next phase in line. All right, so if you're going down, then you're rotating anti-clockwise there. If you're going up, you're rotating clockwise there. All right, just like that. So you can always imagine how these triangles are going to complete the 2 faces by rotation. Okay, so among all the answers for A, of course, if you can see that this triangle rotated 90 degrees, it's going to be overlapping with the one on top, right? Which means that that's definitely not a phase. So A doesn't work. As for B, when I'm rotating these, you can see that it's going to go there and it's going to go there, right? This is going down 90 degrees. This is going up 90 degrees. So again, they're overlapping with some emptiness there, which means that B doesn't work. As for C, if you rotate this triangle up for 90 degrees, it's going to fit in there, which means that this is one of the faces. And if you're rotating this up 90 degrees, so you're going to have that triangle right there. If you're rotating this triangle down for 90 degrees, you're going to have that triangle right there, which means that now I have completed a net like this. Which is the net of a cube. So C is the correct answer. And if you try D and E, you will see that, well, they're just going to either overlap with each other or just doesn't work, basically, because they overlaps. All right. So that's how we can solve this question, by rotating it. Okay? And for the 20th question, this is a question about miscellany. And it will be about the worst case scenario. So it says that there are 10 identical yellow socks, 8 identical blue socks, and 4 identical pink socks, where this person is trying to pick some socks from the drawer. What is the smallest number of socks she must pick to make sure that she has at least 2 pairs of matching socks, which means that 4 socks of the same color? Does it make sense? Or like 2 pairs of different colors, which means that at least there should be 4 socks, 2 of a kind, right? And well, basically, how can we think about this question? The first thing is, what is the most number of socks you need to pick to make sure that there is 1 pair of matching socks? So you can think about it. The most unlucky case, or the worst case scenario, is going to be 1 each of the 3 colors, right? And then when you have 1 of each color, no matter which color is the sock that you're going to pick next, you're going to get a pair, right? So now you have drawn 4 socks, but you just have 1 pair of matching socks. So if I need 1 pair of matching socks, I need to draw 4 times, which means now I have 1 yellow, 1 blue, and 2 pinks. All right, the color doesn't matter. The color doesn't matter. What matters is what's going to happen next. Can you guarantee that the next time you draw a sock, it must form a pair with the existing socks? Not really, right? Because if I'm adding 1 time, I can just pick another pink sock, if I am that unlucky. So it means that I need to draw a sock 1 more time to make sure that I have 2 pairs of matching socks. Because now, whichever color I am drawing, it's definitely going to form a pair with these single socks, right? So we need to add 1 more time, which makes the answer 6. Does it make sense? All right, so this is like the worst case scenario in miscellany. As for question 21, so this is just a simple counting question, and it's about enumerating the different cases. So you might have seen this question before. It was adopted by a lot of past 11 plus papers, so you might have seen it. Basically, which of the options should replace this underline to make the sentence in the box true? And the sentence is saying there are a number of vowels in this short sentence, which means that first of all we can try to count the vowels in this sentence. And there are 12 of them, right? And is the answer 12? Definitely not, because when 12 is put into that box, there will be 2 more vowels, right? Which means that there's going to be 2 adding 12, which is 14 vowels now, which means 12 is wrong. And as for 13, there are 3 vowels, which means that there should be 15 vowels altogether in the sentence if 13 is put in there. So not 13. 14 has 4 vowels, so 12 adding 4 is 16, which is not 14, so 14 is not the answer. 15 has got 3 vowels, So 3 adding 12 is 15, which matches the statement, right? So the answer is going to be 15. And at last, 16 has also got 3 vowels. 3 adding 12 is 15, which is not 16. Okay, so that's how we can find the answer to this question. Just like that. And for question 22, so I would say that this question might be a little bit challenging for you because the diagrams are not given, right? Diagrams are not given. But we actually don't need the diagrams in this problem of angles, because what it is actually asking you is to solve the simultaneous equations. So this is a pretty tough question, it is. You might ask me, oh, there's no x and y, so how can we do a simultaneous equation right there? So here's how it works. First of all, we know that these 3 angles are the 3 different angles of triangle PQR, right? Which means that they adds up to 180 degrees. Does it make sense? In other words, if I am replacing these 3 angles by whatever they are, it means that 2 times angle UST, adding 2 times angle SUT, adding a fifth of the angle UTS is equal to 180 degrees. But we also know that STU is also a triangle, which means that these 3 angles added up should also be 180 degrees. So for simplicity, I'm just going to write it in one statement. So now you can easily see that on both sides of these equations, I have the 3 angles of the triangle STU. And after you're doing a little bit of simplification there, you will see that, well, definitely the 180 does not needs to be there now, because I have already connected these 2 expressions, right? So I can just simply equate them to each other. So after a little bit of simplification, you will see that angle UST adding angle SUT is equal to 4/5 of angle UTS. And that definitely helps, because these 2 angles can be replaced by 4/5 of angle UTS, which means that 180 degrees is 4/5 of UTS adding UTS. That is 9/5 of angle UTS. So now I can just carry on to solve this equation to find angle UTS, which is 100 degrees. All right, multiplying both sides by 5 and then divided by 9. That's how we can solve a fractional equation. Does it make sense? So basically it's about substitution. It's about substitution when you have some equivalent conditions. And you need to know what to substitute and why are we substituting this. For example, why am I replacing this by this? That's because such that I can just try to describe everything in terms of one unknown to find that single unknown, which is what we want. Yeah. So that's it for this question. As for question 23, it is basically just some calculations as long as you have understood the rules. So it belongs to miscellany, and that's going to be the filling number games. So it says that each square after the fourth from the left is the sum of the numbers in the four numbers to its in the four squares to its left. So let's say these empty boxes are A, B, C, and D now. It tells me that every square is the sum of the four to its left, right? So it means that 1 comes from A adding B adding 2 adding 0, or in any order. Which means A adding B is equal to -1. So we still don't know A or B, right? But it doesn't really matter because the next box, C, is adding A, 0, B, and 1. We know that A and B adds up to -1, so I have 0 adding -1 adding 1. That is equal to 0. And now, the next box is 8, which comes from 0 adding B adding 1 adding C. And that's 8. Wait, but we don't know C. We don't know B, right? It doesn't really matter because we already know C. C is 0, which means that B adding 1 is 8. That means B is 7. So finally, we can definitely find D, because D is B adding 1 adding C adding 8, which is 7 adding 1 adding 0 adding 8. Oh, D is equal to, and that's equal to 16, right? So the answer is going to be 16. That's how we can solve this question. You just need to think about A and B as a whole temporarily. All right, and you'll be able to find out the rest of them. And for the next question, this one is interesting. So again, this is a question in geometry. And it's about perimeters. But then actually, it is still testing you on the simultaneous equations. So let's see how it works. Basically, the shapes P and Q are formed by 2 and 3 identical rectangles. Their perimeters are 58 and 85 respectively. And I want to find the perimeter of one of the rectangles. So, if you know that you can try to pop these shapes up, it might be a little bit easier for you. So, like, for example, I can make it look like this, but with 2 extra lines, right? So, how can we describe the perimeters then? For the first one, after popping it up, I know that a length is a length adding a width of the small rectangle, and a width of this rectangle P is going to be a length of the small rectangle, right? So altogether, I can say that 4 lengths and 2 widths is equal to 58, right? That's the perimeter of P. And as for Q, you can see that each side is going to be a length and a width, a length and a width, a length and a width, a length and a width. But then we still have the 2 middle ones, yeah? And each of these middle ones is a length, take away a width. So for the second one, the equation is going to be 4 lengths adding 4 widths, adding 2 times of length take away width is equal to 85. which means that we can simplify it into 6 lengths, adding 2 widths is 85. Now I have 2 simultaneous equations about lengths and widths. Let's say this is the first one, this is the second one. If I am taking away the first one from the second one, I will see that 2 lengths is equal to 85, take away 58, that is 27. So how do I find the widths? Well, actually I don't need to find the widths on their own. Because what are we looking for? We are looking for the perimeter of one of the rectangles, which is 2 widths adding 2 lengths, right? All I need to do is just to remove this, let's say that's the third equation, from the first equation, such that 2 widths is going to be removed. What's remaining is 2 lengths adding 2 widths. And of course, on the right hand side, you need to do the subtraction of the numbers 58 and 27. That's giving us 31. So the answer is B, 31. All right. So first of all, it's not easy for you to list these equations because you would need to know what to set as the unknowns. For example, like length and width of the small rectangles, right? And also you would need to know how to express them. Express the perimeters using these lengths and widths. So that's basically the key to this question. All right. And then for the last question, question 25. So this time I need to hide my head because this is a more complex geometry question on the interior and exterior angles. So this time there is no specific tricks in it. All you need to do is just calculation of the geometry. So you need to know all the definitions in geometry really well. All right. So the first thing is that it's telling you that these two are the sides of an n-sided polygon. And it's telling you that these two angles are 80. This angle is 70. Now, the remaining condition is that these 3 sides are the same. And it is asking you how many sides does this polygon have? Well, this is kind of a tough question, is it? So how do we know? How do we know? Basically, to find the number of sides for a polygon, there will be 2 ways we can do it. The first way is if I know an interior angle, I can try to use the interior angle formula to find the number of sides. Or if I know the exterior angle, well, so this is the interior angle, let's say this is I. This is the exterior angle, E. If I know the exterior angle, I know that for any polygons, the exterior angles are going to add up to 360 degrees. So I can also use that to find the number of sides, which definitely using the exterior angle is going to be easier than using the interior angles. But in this question, if I want to know the interior angle, if I want to know the exterior angle, I need to know the interior angle. So now let's take a look at where the interior angle is positioned in this diagram. It is right there, isn't it? So it means that it is placed in the quadrilateral SRQP. Now, we know 2 of the angles, 80 and 80, but I don't know the top angle. So how can we find the top angle? Basically, we know that these 3 sides are all the same, right? So I can say that these are 2 isosceles triangles right there. Which means that the base angles should be the same. So let's say these are X angles and these are Y angles. All right. So basically, if I want to know the top angle, I'm looking for x adding y. Yep. So now, let's name these two angles A and B. There are a lot of these unknown angles, but then actually, all I want to know is x and y, right? So I need to think about how we can find x and y. First of all, using the interior angle sum of triangle, I know that A adding 2x is 180 degrees. I also know that B adding 2y is 180 degrees. And how do I get the values of A and B? I know that A adding B adding 70 degrees. That's the remaining condition we haven't used, right? That is 360 degrees. So if you can spot this, you can just combine these two equations together such that A adding B adding 2x adding 2y is 360 degrees. Now, comparing these two equations, you can see that AB and 360 are the same, which means that 2x adding 2y is 70 degrees. So definitely we know the top angle, x adding y, is just that divided by 2, is 35 degrees. So this angle is 35 degrees. Now, of course, I can find the interior angle. The interior angle is going to be 360 degrees, which is the sum of interior angles of a quadrilateral. Take away 35 degrees, take away 80 degrees times 2. And that's going to give us 165 degrees. All right, so the interior angle is 165 degrees, but as I said, it would be easier if I'm using the exterior angle, right? And definitely we know that angles on a straight line is 180 degrees, which means that the exterior angle is 180, take away 165, which is 15 degrees. And because all the exterior angles adds up to 360, and the number of exterior angles is equal to the number of sides it has, right? So, because for a regular n-sided polygon, it has n sides, n vertices, so definitely there will be n exterior angles, right? Each vertex has one exterior angle. So, we just need to divide 360 by 15, and that's going to be n. So it's going to be 24. That's a pretty long deduction process, and I would say that this is kind of a slightly more complex geometry question for your age, but as long as you're familiar with all these kinds of rules and laws in geometry, you will be able to solve it easily. Okay, so that's it. That's everything for today. Thank you all for listening, and I will see you next time. All right, bye bye.